Okay, hi everybody. Okay, so today we're going to go over 76 through 84 of your practicing your purple practice exam. Okay, so let's just jump right into it. Okay, so the first one, the graph of the function f is shown above. Which of the following statements must be false? F of a exists. It does clearly exist. It's right there. So this is true. Okay, B, f of x defined for 0 to a. So there's 0, there's a. If you notice, I can go anywhere up on there on the graph and it will hit a point in the graph. Okay, so this is defined, so that's true. Okay, f is not continuous at x equal to a. That's true because if you try to draw it, I know this is a bad definition, but if you try to draw it, you'd have to pick up your pen to draw it, and so it's not continuous. That is a true statement. Okay, the limit as x goes to a of f of x exists. That is also a true statement. And the reason why is because remember, limits have to approach the same value from both directions. So as it goes to it from the left, or if it goes to it from the right or negative side or positive side, it's going to go to whatever that same y value is. So this is a true statement. Okay, and then the last one, the limit as x goes to a of f prime of x exists. That is a false statement. And the reason why is because, once again, in order for that to have happened, it has to approach the same thing from both directions. So if you approach it from the left and you approach it from the right, you notice the derivative is the slope of the tangent line. So the slope of the tangent line would be positive here. It'd be negative. The positive won't approach the negative value. So this is a false statement, and my answer is E. Okay. Next one. Okay, so next one right here. Let's see if I can zoom in a little bit better on this. Seems a little bit far away. Okay, here we go. So we're going to let p of x be equal to 3x squared minus 5x cubed plus 7x to the fourth plus 3 is fifth be a fifth degree Taylor polynomial for the function f about x equal to 0. That actually means it's Maclaurin. What is the value of the third derivative of 0? Okay, so we should know that in a Maclaurin series, each term along the way is found by taking the nth root evaluated of the function, evaluated 0, times x to the power of n all over n factorial. Each term of a Taylor series centered at zeros will be determined by this equation, by this expression. So if you go up here, each one of these terms, 3x squared, was found by this. 5x cubed was found by that. 7x to the fourth was found by this equation. So just go ahead and continue this. Okay, so I want to know what the third derivative is, so I'm just going to plug in 3 here. So I want to know what the third derivative is, evaluated at 0. Well, if this is a 3, that means that has to be a 3. So this is x cubed all over 3 factorial. Now, if I go up here, and I know that this equation was found by using this formula, then the x cubed should match up with the x cubed. That means that this is equal to negative 5x cubed. Okay, I can ignore the x cubes. That's not really important part of this problem. And then multiply 3 factorial 6, multiplying it up, you have the third derivative of value at 0 is equal to negative 5 times 6, so you have negative 30. The answer is A. Let's get that out of the way. Okay, next page. Okay, so the radius circle is increasing at a constant rate of 0.2 meters per second. What is the rate of increase of the area of the circle at the instant when the circumference of the circle is 20 pi centimeters? Okay, hopefully you recognize that this is a related rates problem. So the way that I've always taught it is you write down what you know and you write down what you're trying to find. So this says the radius of the circle is increasing at a constant rate of 0.2. What that means is that dr dt is going to be equal to 0.2. Okay, so that's one thing that I know. Now, what am I looking for? I'm looking for the rate of increase of the area. So I want to know what is dA dt. That's what I want to know. Okay, and then they also give me this random part of the circumference being equal to that. Circumference is equal to, and I'm writing this down and you'll see why in a second. The formula is 2 pi r, which is equal to 20 pi. Okay, so those are the bits and pieces that I know. Okay, now what I've always taught is that I need an equation that's going to relate A to R. area of a circle to the radius of a circle. Well, you know what that formula is. It's A is equal to pi r squared. So this is going to be the equation that's going to connect A with r, but now I need to access dA dt and dr dt. So I come down here, take the derivative of both sides with respect to t. So I have dA dt is equal to 2 pi r, but I'm taking the derivative of r with respect to t, so I have dr dt. Hopefully at this point in time, you're able to see why I wrote circumference as 2 pi r. Look, 2 pi r. So I plug it in. So this is equal to 20 pi, because that's what 2 pi r is equal to, times dr dt, and dr dt from up above is 0.2. So this is 0.2. When you multiply it out, you get 4 pi. So you come over here, and your answer is C. Okay, next question. Classic type of a question here. They give you the box, you have to fill it in. This one, when you see it, you should be really happy on the BC exam. Okay, so the table gives the functions are the values of f, f prime, g, and g prime at the selected values of x. If h of x is equal to f of g of x, then h prime of 1 is equal to what? Well, the first thing I need to do is I need to figure out what h prime of x is equal to. So I go up here and I take the derivative of this. So I take the derivative of the outer, the g of x stays the argument inside, but by the chain rule, I need to multiply by the derivative of g of x, which is g prime of x. Okay, now I just evaluate this. So if h prime of 1 is equal to f prime of g of 1 times g prime of 1. And now I go up to the table here to figure out what these values are equal to. So g of 1, here's g, there's 1, so g of 1 is negative 1. So this is f prime of negative 1 times g prime of 1. Here's g prime, there's 1. G prime of 1 is 2. So continue along. So f prime of 1 is negative 3. So I have negative 3 times 2. So I get negative 6 here. What did I do wrong? Let's see. So g of 1. So g of 1 is negative 1. That's a negative 1. And g of negative 1 is 3. So this should be 3. And then f prime of 3 is going to be negative 2. What is going on right now? Okay, so f prime of g of x times g prime, f prime of g of, no, this is positive 1. Let's start over. Sorry, you guys. Let's go over here to the side here. Okay, so using this again, I have h prime of 1 is equal to f prime of g of 1 times g prime of 1. So that's equal to f prime of g of 1. G of 1 is negative 1. So this is f prime of negative 1 times g prime of 1 is 2. And then we go f prime of negative 1. Oh, here we are. F prime of negative 1 is 5. That's where I goofed up. So 5 times 2, which gives you 10. So the answer here is D. Sorry about that. I got going a little bit too fast and didn't keep track of what I was trying to do. Okay, next page then. Okay, number 80. Okay, so insects destroy a crop at the rate of 100 e to the negative 0.1 t over 2 minus e to negative 3 t tons per day. That is the rate, where t is measured in day. To the nearest ton, how many tons did the insect destroy during the time interval from 7 to 14? If you want to know what the total amount is, you integrate what the rate is. So this is the rate, so we're just going to integrate it from 7 to 14. So I have the integral from 7 to 14 of 100 e to the negative 0.1 t all over 2 minus e to the negative 3 t dt. Punch in this into our graphing calculator. We get 124.99. So you can see the answer is A, 125. Okay, next question. 81. The graph of f is shown in the figure above. The value of the limit as x goes to 1 of sine of f of x is, be careful here. The thing that they want you to do is just plug 1 in and figure, okay, f of 1 is 3, and then take sine of 3. But that's not how you do it. Okay, remember, it's a limit. Now, limits are nice here. You can actually pass it inside. So you're going to have the sine of the limit as x goes to 1 of f of x. Oh, there's no dx there. Of f of x. Now, what is the limit of f of x as x goes to 1? Remember, it's the y value that it approaches. So as it approaches it from the negative side, it's going to 2. As it approaches it from the positive side, it's going to 2. So this is actually the same thing as sine of 2. And sine of 2, plugging into our calculator, gives us a 0.909. Okay, a couple more. 82. Okay. The rate of change of the altitude of a hot air balloon is given by this. Once again, this is the rate, so this is the derivative of whatever the position function is, from 0 to 8. Which of the following expressions gives the change in altitude of the balloon during the time the altitude is decreasing? So if it's decreasing, that means the derivative is going to be negative. Okay, now I'll leave you to do this on your own. But when you graph the rate, it will look something like this, and just this portion anyway. Okay, so it goes like this, where this x-intercept turns out to be 1.572, and I ask you to verify this on your own with your own graphing calculator. And this x value is 3.514. So from 1.572 to 3.514, I know the derivative is negative. That means that it's going to be decreasing. So I need to integrate from 1.572 to 3.514. And if you notice, my answers here could be, it should be dt here, excuse me. So it could be A or it could be D. Now, what do you integrate? You integrate the rate, remember, to find out the total amount. Well, the trick here is you think rate, oh, that's the derivative. But remember, this is the rate. R of t is actually the rate of this. So we just need to integrate R of t. So the answer is actually A here. Okay, a couple more, 3 more, I think. No, 2 more. That's it. Okay, number 83. The function of f is continuous and differentiable on the closed interval from 0 to 4. The table above gives the selected values of f on this interval. Which of the following statements is true? Now, I want to point out something real quick. This isn't 100% of the time, but when they drop the fact that a function is continuous and differentiable on an interval, you should be thinking mean value theorem or and roles. Okay? Either one of those. That's what you should be thinking. Doesn't mean that that's what it's going to be, but that's what you should be thinking. Okay? So anyway, so which of these must be true? The minimum value of f on 0 to 4 is 2. It looks like it, but you have no idea what's happening between 0 and 1 because it is a continuous function. So this is a false statement. Okay, the maximum value of f on 0 to 4 is 4. Once again, that looks like it's true, but for the same reasoning, I have no idea what's happening between 0 and 1, so this is also a false statement. And C, f of x is greater than 0 between 0 and 4. Well, once again, it looks like it, but we have no idea, so this is false. The derivative, once again, I have no idea what's happening between those, so this is false. Now there exists a c with c between 0 and 4 for which the derivative of c is equal to 0. So if you remember what I said when I read this originally, I should be thinking to myself mean value theorem or roles, and that's exactly what it is. Remember, for roles to have happen, it has to be continuous and differentiable. It is. And f of 0 must be equal to f of 4 for roles. Well, if you notice, f of 0 is 2, f of 4 is 2, so that is true. And then this is exactly the statement. If it's continuous, differentiable, these two things are equal to each other, then there must exist some c value between 0 and 4 for which the derivative is equal to 0. So that is a true statement. So the answer is E. Okay, and the last one. Okay, particle moves in the xy plane so that its position at any time t is given by x of t is equal to t squared and y of t is equal to sine of 4t. What is the speed of the particle when t is equal to 3? So speed, if you recall, speed is the magnitude of the velocity vector. Okay, so I'm going to set up a position vector so I can find the velocity vector. So the position vector is given by t squared, comma, sine of 4t. That's what the position is, which I can represent as x of t. So then the velocity vector v prime of t is going to be equal to 2t, sorry, comma, 4 cosine of 4t. So all I need to do to find the speed is take, this is not v prime, is take the magnitude of what this is. Okay, so the magnitude, if you recall, of a vector is the square root of its derivative squared. So that is going to be 2t squared plus 4 cosine of 4t squared. Okay, and then I just need to evaluate this when t is equal to 3. So the speed at time is equal to 3 is equal to the square root of 3 times 2 is 6. 6 squared is 36 plus I'm going to have 16 times cosine of 12, cosine squared of 12. And evaluating this, I end up getting 6.884. So the answer is C. Okay, so that was 76 through 84 today. And thanks for watching.